Good morning, everybody, and welcome to our online course. Today, what we are going to be working on is on lesson 5, which is loss of logarithm. Let's just dive right into this and we'll keep on working. So, we saw from the previous lesson that logarithms are necessary to solve exponential equations that can't be solved using the same base technique. So what we're gonna do today is like there's has to be a different way to solve logarithm equations that are not the same base. And these are the laws of logarithm that we're gonna do. And it says here it's found on your formula sheet, and then I'm just gonna show you what that formula sheet looks like. Um, this is something that we received in class when we were still in class. That's this one right there. Okay, so these are laws of logarithm, three of them. Um, and you'll probably find that the laws of logarithm really is connected to the laws of exponent, right? So when we look at this one here, when you have to multiply the power um, of the same base, okay, power of the same base, what we're doing is we're adding the exponent. That's why it says there log of m plus log of n. Okay, so this is really kind of talking about how laws of exponents are connected to the laws of logarithm. And says here when we have a power of the same base that are being divided, what do we do to the exponent? We subtract the exponent. So that's why here log of m minus log of n. And then this one here is a power to a power. When you have a power raised to another power, um, for the base a, what do we do to the exponent? We, we multiply the exponent. So that's why it's n, exponent n, times the log of m, which is the log of m is an exponent for a. So we're going to really work on these ones today, and we'll see how that goes. Quite a bit of stuff we're going to do today. So we are on page 18. So laws of logarithm, then you'll probably find the same laws of logarithm on your booklet, just in case your formula sheet is somewhere else. So log base a of m times n, we can rewrite that as log of base a of m plus log base a of n. If they're being divided, right, m divided by n, this is when you think about the laws of exponents. When you're dividing, we are subtracting the exponent. That's why there's a subtract in here. So log of m base a and log of n base a, subtracting them. And then this one here is going to be n times log of m base a. These are the helpful to know, because we might come across this one here. It says here log of a to the n base a. So what they're really saying is what exponent do I apply to a so that it becomes a to the n? Well, that's n. That's why it's n. And then here, this is same thing, asking ourselves a question, because logarithm is something that we've never really seen before until this semester. So logarithm is asking ourselves, what exponent do I need to raise a by? What exponent do I need for base a, so that a to something will give me 1? Well, a to the power of 0 is 1. And then here, log, what exponent do I need to apply to a to get an a? Well, it's 1. So these are things that are helpful to know. And we're going to use that later on as well. Um, the laws of logarithm, the the way we're learning this now is actually going to be really, really helpful when we are going to try to solve for logarithm equation and exponential equation. So this is important. Important. I'm just going to write it down in here. Important skill to know when we need to solve log equation and exponential exponential equation. Okay, we've done exponential equation prior to this, but exponential equation using the same base, we're going to come across where it's not the same base. So let's take a look, dive right in. So example number one is just an exercise on how to rewrite as a single logarithm. So how can we rewrite this as a single logarithm? So there are two exponents are being added. Okay, remember logarithm is just an exponent. So two exponents are being added. So how can we rewrite that? So that means these two powers got multiplied together for the same base of 4. So that becomes log of x times y. I can put it inside the brackets to combine those two, base 4. Okay, so that one's easy. So this is the using log base a of m times n is equals to oh, log of m base a plus log of n base a. So we're using this um, exponent rule, logarithm rule. And that's our answer. Now you take a look at this one. Two things are subtracted, okay? Two exponents are subtracted. So that means we can rewrite that as log of, if it's subtracted, it means that these two have to be divided. So it's going to be x squared divided by y. I can put that inside the brackets again, and then I'm going to write down base 2. So log of x squared divided by y base 2. Okay, so that one is that. That one is not bad. It's pretty simple. Now we're going to get into the next page. Okay, this one is a little bit more complex because it has more stuff going on. We're going to write that as a single logarithm. Okay, so write as a single logarithm. So what's happening in here is that these two got added, and then this subtracting this one, and this part in here, okay, 2 times log of x base 3. I'm actually going to write it down in here. So the 2 will be the exponent there. So it becomes log of x squared base 3 plus, okay, again, the exponent 4 here will be, sorry, the 4 here will become the exponent for y. So that becomes log of y to the 4th base 3, and then minus log of z. Okay. So what's going to happen in here is that these two got added. So if these two are added, and then this one is subtracted. So that means we can rewrite it as log of x squared times y to the fourth base 3 my I just want to let you know that I'm doing these two first. Okay, showing every single part of my work here. So I added these two, and if I these two logarithms are added, that means we're multiplying x squared and y to the fourth, and then minus log z base 3. Going to go this way. Now, if it's being subtracted, that means these two are being divided. So that becomes log of x squared y to the 4 divided by z. All of that is base 3. Okay, so yep, showing of our work every single step. Um, if you could just jump from one thing to the other, like you can go from here to there, then that's great. But I like showing my work here. Now let's take a look at this one here. What's happening there? So this is ln, okay, ln is pronounced as ln, and this is operating with base e, the 2 point, approximately 2.7. X minus 4 minus 2 times ln of x plus 5. So the first thing that I'm going to do is I'm going to put this over there. So ln of x minus 4 minus ln, natural log of x plus 5 exponent 2. Okay, now that I have that, I can see that these two are subtracted. These two exponents are subtracted. That means x divided by 4 has to be divided by x plus 5 squared. So natural log of x minus 4. Yeah, I could do that. X minus 4 divided by x plus 5 squared. Okay, I'll bring the natural log a little bit closer. It's kind of far. So natural log or ln of x minus 4 divided by x plus 5 squared. Okay, so those four examples are just a practice or an exercise on how to get the expanded logarithm expression and then writing it as a single logarithm expression. Okay, so nothing is equation here, so all of these are expression. So now let's take a look at example number 2. Use the laws of logarithm to expand each expression. Now we're going to take a single logarithm and then we can expand it. Okay, this is going to be super important when we get into solving exponential and logarithm equation. So let's do that one. So if you look at this one in here, x cubed times y. So this is the power because these are the power of the same base 5. What would that be? If they're being multiplied, that means exponents are added. So that is going to write it this way. Log of x cubed base 5 plus log of y base 5. Okay, so splitting them up, right? That's if they're being multiplied. Now, another thing that I can see here is that this is x cubed. So we can expand that even more and say it's going to be 3 times log of x base 5 plus log of y base 5. And that's about it. Okay, we can stop right there. Take a look at letter B. X log of x cubed over y base 4. Okay, log of base 4, log base 4 of x cubed divided by y. So as you can see here, these are being divided. So that means the exponents really are being subtracted. So that becomes log of x cubed base 4 minus log of y base 4. Okay, and then now here I can see that this is x cubed. We can rewrite that as, bring this out there at the front. So it's going to be 3 times the log of x base 4 minus log of y base 4. Okay. So those ones are, yeah, do it one at a time. When you had divided, right? They're being divided so that you can split them up into two exponents, log of x cubed divided by y, log of y, and then do the exponent after, right? Do it one at a time, slowly and carefully. Now let's take a look at this one. What does this mean, square root? Okay, so before we dive right into that one, we can say, remember, square root is really means exponent to the 1/2. So let's say this is an index of 2, say x, so x to the 1/2. So the 2 would be the denominator of the exponent, and then the 1 would be the numerator of the exponent for base. So if you don't remember these ones, this is the exponent using a rational exponent, changing the rational exponent to a radical. Okay, so going back to this one, okay, what do we know? So this square root is applied to all of these, so that's a great thing. I can go ln of a times b to the 4th, and then the square root, that's the same thing as exponent 1/2. Okay. Good. So that's the first part. Now here's the other thing that we can do. Remember that all of these exponent to the 1/2 is applied to all of these things. So if I go here, if I bring that 1/2 to the front, so 1/2, remember that this 1/2 applies to everything there. So I gotta go natural log or ln of a b to the power of 4. Okay, and let that kind of, I'm going to give you a moment to just think about that one. Okay, so remember that 1/2 is applied to all of these inside the brackets. I'm actually going to show you an alternative version of this, which we will get to the same answer anyway. So now looking at this one, ln of a b to the 4th. That's the same thing as 1/2 times, because this is being multiplied, then that's can be ln of a plus ln of b to the 4th. Okay, I'm just gonna, I'm quickly running out of room, so I'm just gonna switch over to this side here. I can see that b is raised to the exponent 4, so I can bring that 4 to the front. So it's going to be 1/2 natural log of a plus 4 times natural log of b. And then from here, we can just multiply in. So we can say that's the same thing as 1/2 natural log of a plus 1/2 times 4. We can just rewrite that as 2 natural log of b. So that's that's the completely expanded version of that. Okay, so what I'm going to do is I'm going to just mm, 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 mm. I want to show you an alternative way of this. Okay, I'll just show it on a separate sheet of paper. So I'm just going to write down page 19, example 2, 2C. Okay. So here's an alternative way of doing that one. Okay, and then we should be able to get to the same answer. And let's see how that goes. Okay, starting off with natural log of square root of a b to the fourth. Okay, I like this one because I have more room. So same thing, square root can be written as exponent to the 1/2. So natural log of a b to the 4 to the 1/2. Okay, so what I could do is now um, I can use the laws of exponent, so power to a power. So I can say, hey, this is going to be natural log of a to the 1/2, and then b. Okay, so this is exponent 1. 1 times 1/2 is 1/2. 4 times 1/2 is 2. There. So I've multiplied the 1/2 into those um, exponents. Now I have this one. I can see that these two are being multiplied, so I can split them up into the sum of the logarithms. So natural log of a to the 1/2 plus natural log of b squared. Okay, now I have this 1/2. I'm going to bring it to the front, so I can go 1/2 natural log of a plus, and I bring the 2 to the front, and that's going to be 2 natural log of b. And as you can see, that's the same answer that we got here. Same answer, slightly different approach, but we get to the same answer. Okay. So now let's. And if you're watching it live right now, and if you have some questions or you're not sure on how I got to that, you can send me a message, and then yeah, I'll try to solve it for you or answer that question for you. So over here, we're going to do example 2, letter D. Again, this is a one single logarithm. What we're gonna do is we're going to expand it, and then we'll see from there, okay? Okay. So this one here, I have log of cube root of 36x divided by y squared, base 6. Okay, so how can we do this first? Well, what we can do is, because these two are being divided, so we can split it up into subtracting two logarithms. So we can say log of cube root of 36x, and then again, that's base 6. I'm going to put base 6 minus log of y squared. Okay, so the first thing that I'm doing is dealing with this division there. Okay, now what are we going to do next? Now this is cube root. We can rewrite that as, so cube root is exponent, can be written as an exponential expression to the power 1/3. So we can write that as log of 36x to the 1/3. Okay, base 6. Oops, I forgot base 6 here. Minus log um, y squared base 6. So that's the first thing that I did, was to change this radical into the exponential form. So cube root is the same thing as 1/3, exponent to the 1/3. Okay, so what are we going to do next? Um, Here's what we could do. We can you see this 1/3 here? We can bring it to the front, and we can say that's 1/3 times log of 36x base 6 minus, and then you take this square, 2 log y base 6. Okay, now this 1/3, what we're going to do is we're going to expand these two, this one, but this 1/3 is applied to all of those things. So I'm going to just multiply that, or not multiply, yeah, put a brackets there so I know that I can do the multiplication later on after I expand this thing. So 1/3, it's going to be log of 36 base 6 plus log of x base 6 minus 2 log y base 6. Okay, what else can I do? Oh, here's what we could do. We could actually evaluate this one in here. We can figure this out, find a value. Log of 36 base 6. So what does that mean again? What does a log mean? It means what exponent do I need to apply to 6 to get to 36? So what exponent do I need for 6 to get a 36? Well, that's 6 squared is 36. So that's the same thing as 1/3 times 2. Okay, so that's that one. Plus this one here, we cannot figure that out because I don't know what the x is. So it just becomes log of x base 6 minus 2 log y base 6. And then again, we can multiply this in. So we can say it's going to be 1/3 times 2 is 2/3 plus 1/3 times log of x base 6, log of x base 6 minus 2 log y base 6. Okay, so that's that. Okay. Now, I'm gonna give you an alternative way of doing this. Okay, let's see an alternative way of doing that thing. I'll just do it as a separate sheet of paper. Mhm. This is gonna be page 19, example 2D. Okay, so giving you like a slightly different approach because sometimes slightly, well, we will get the same answer anyway. So let's try that one. Log of the cube root of 36x over over y squared base 6. Okay, so how can we approach that? So I can say, hey, I can go log of these are being subtracted, so that's cube root of 36x minus log of y squared. Okay, all of these are base 6. And then, so it's same starting point. And then I can go, oh, I can see that this is cube root, so I can write that um, as a rational exponent. So log of 36x to the power of 1/3. Okay, that's base 6 minus, and then here log of y squared base 6. Okay, so again, that's looks like it's pretty much the same thing as the other one. Now this is where it's gonna start to look a little bit different, just a little. As you can see here, 36x to all of that is to the power of 1/3. So what I can do is apply the power rule over here. I can write that as log of, okay, base 6 again. That's 36 to the 1/3 times x to the 1/3. Okay, minus, and then this one I could deal with this. I can put the 2 at the front. Log of y base 6. Okay, so by doing the power rule over here, okay, 36 to the 1 to the 1/3 to multiply exponents, and this is what I will get. Now over here, these two are being multiplied, 36 to the 1/3 times x to the 1/3. So I can rewrite that as log of 36 to the 1/3 base 6, because it's being multiplied, it's the exponent is being added. Log of x to the 1/3 base 6 minus 2 log y base 6. Okay, so now you'll see that, oh, it's starting to look a little bit different, just a little. This part is different. Now, this exponent 1/3, I can bring it to the front, and then this exponent 1/3, that goes to the front. So that becomes 1/3 times log of 36 base 6 plus 1/3 log of x base 6 minus 2 log y base 6. And then once I get to this point in here, oh, okay, I see that log of 36 base 6. I could figure this out. 6 to what exponent? What exponent do I need to apply to 6 to get a 36? That's exponent 2, so that's the answer is 2. So 1/3 times 2, so all of these is really 2, plus 1/3 log of x base 6 minus 2 log of y base 6. And as you can see, this one can be simplified that as 2/3 plus 1/3 log of x base 6 minus 2 log of y base 6. So as you can see, we ended up getting the same answer, two different approach, but same answer. Okay, so all of these will be posted on the blog. Okay, so the steps are the steps are shown along the way, like little steps along the way, so that you can read it and you can see what just happened there. So that's that. Okay. So if you have any questions, feel free to ask. And otherwise, I'm gonna keep going. Okay, so here we go. We're on page 20. Page 20, example 3. It says, use laws of logarithm to evaluate each expression. Okay, now this one here, we're going to evaluate this. Evaluate means what is the answer to this expression, right? It's not. So what we're going to do, and this one is a little bit challenging to do without the laws of logarithm. So you can see here, what exponent do I need to apply to 4 to get 8? Okay, so that one's a little bit challenging, right? Because we know 4 to the 1 is 4, and then 4 squared is 16. So this is not going to be an easy one to think about right away. Now over here, log of 32 base 4. It's asking what exponent do I need for 4 to get a 32? And again, we don't know, right? So, and then we can't even put that into our calculator because our calculator only has a common log base 10 and natural log base e. We don't have on our calculator, well, our regular calculator, have a base 4. So, what can we do? What can we do? Okay, let's see if we can apply loss of logarithm in here. Okay, what can I do here? Oh, okay, so I know that because these two logarithms are being added, I can go log of 8 times 32 base 4. Okay, so 8 times 32. Well, what's 8 times 32? Oh, I don't know. Let's figure that out. 8 times 32. I mean, I could do that mentally, but I'm just going to use a calculator. So I mean, I could have done that mentally. So 2 times 30 is 240 plus 2, 8 times 2 is 16, so it's 256. So that was not super bad. Now I'm going to go here. The question that I'm thinking about is what exponent do I apply to 4, to base 4, to get 256. That's basically what logarithm is, trying to figure out what exponent do I need for base 4 to get a 256. Well, we figured that out before because this is a nice number because it's 4. 4 to the 1 is 4. 4 to the 2 is 16. 4 cubed is 64. 4 to the 4th is 256. So that means exponent 4. So I can just go here. Log of 256, I can write it as 4 to the 4. So what exponent do I need to apply to 4 to get 256? Well, 4 to the 4th is 256, so the answer is 4. So that was, we were able to figure that out. It's exactly 4 using our laws of logarithm. Now this one here, oh, this one's super easy. Um, I don't even know if I need to write that down here. Um, log of 81 base 9. So what exponent do I need for 9 to get an 81? So I can go, okay, log of 81. 81, I can go 9 squared, right? So log of 9 squared with base 9, so that would be 2. The answer is 2. Okay. Okay, now let's try this one. It's a little bit more complex, but we'll give it a try. So 2 log of 12 base 2 minus all of that. Oh, okay. So how could we do that piece? We can go, what can I do? Oh, I can put this 2 squared there. So it's going to be log of 12 squared base 2 minus, I got to figure all of these out. Log of 6 base 2 plus the 1/3. I'm going to raise to that power there. So that becomes log of 27 to the 1/3 base 2. Everything is base 2. So that's the first thing that I did. So I'll put the exponent, oops, right there and right there. Okay. Now let's see if I can simplify some stuff in here. As you can see, we're looking at the expanded version and then see if we can narrow it down to a single logarithm. Log of 12 squared base 2, that's I can see that's going to be 144. Log of 144 base 2 minus, since these are all inside the brackets, since all of these are inside the brackets, what we're going to do, we're going to deal with that, simplify that one first. These two are getting added, so that means they need to be multiplied, the 6 and the 27 to the 1/3. So log of 6 times 27 to the 1/3 base 2. And you're probably thinking, okay, log of 144 minus 27 to the 1/3. Well, that 27 to the 1/3 is really the cube root of 27. So what's a cube root of 27? That's 3. So we can write that as log of 6 times 3. Again, that's a base 2. Okay, so just to kind of this part in here, cube root, oops, cube root of 27, that's 3. 3 times 3 is 9, times 3 is 27. So now I can go here, log of 144 minus, oh, I lost the base 2, minus log of 6 times 3 is 18, base 2. Okay. Oops. Sorry. Keep pushing it up. Now these two are being subtracted, so that means 144 has to be divided by 18. So log of 144 divided by 18, base 2, And 144 divided by 18 is 8. So that becomes just log of 8 base 2. Now we're going to see here. After all of that, it just boils down to 8. Log 8 of base 2. Okay, so now our question, what are we going to ask ourselves? What exponent do I need to apply to 2 to get an 8? And then the answer is 3, because 3 to the 8, 2 to the power of 3 will give us 8. Okay, wow, this is a really long one. I think I might have to shorten it a bit. Let's see when's the best place to cut this off. Okay, I think I'm just gonna finish up example 4, and then um, we'll have time to like do some work here. It's quite a bit of stuff to take a look at to get used to. So I think I'm just gonna kind of make this a 2 lesson instead of just 1 lesson. So much to think about. Okay, so here, use the laws of logarithm to, again, what are we supposed to do? Not to simplify, but to evaluate. The word evaluate means to find the value of that, the value of that. So the following without the calculator, okay? Without the calculator, if log of 2 is 0.31, I'm sorry, 0.301, and log of 5 would be 0.699, okay? Uh, the tricky part here is without a calculator. So now here's what we're gonna do. How can we create a 50 from 2 and 5? How can we create 50 from 2 and 5? We can say log of 50 would be 5 squared times 2. So I can just say log of 5 squared. Okay, so 5 squared will give me 25 times 2. I'm just going to put times 2. And this one here is base 10, so I don't have to write that. Now from here, what I could do is I can expand it. We can say, oh, okay, I could go here. Log of 5 squared plus log of 2. Log of 2. Okay, now I can go this, bring it to the front. That makes it 2 times log of 5 plus log of 2. And then I can go, oh, okay, 2 times log of 5 plus log of 2. I'll just push it this way. I can rewrite that as 2 times, I know what the log of 5 is. Log of 5 would be 0.699. 0.699 plus log of 2. Log of 2 is 0.301. Okay, so let's see that one. So this is going to be 2 times 0.69999 would give us 18, 18, 19, 12, 13. So 1.398. 1.398 plus 0.301. So I add these two plus 0.301. So this is 996. So it's going to be 1.699. Oh, okay. So that one is my answer. Now, I know it says without a calculator. I'm actually just going to double check my work in here. Log, where's my log button? Oh, there it is. Log button. Log. Let's see here. Logs. Log of 50. Oh, there you go. Super, super close. I got 1.699 and I got log of 50. I typed it into the calculator just to check. Okay, so now take a look at this one. Okay, how can I get 40 from 2 and 5? 2 and 5. So I can go 2 cubed. 2 cubed is 8, and then 8 times 5 will give me 40. So I can go log of 2 cubed times 5. 2 cubed, that's 8 times 5 is going to give us the 40. So that becomes, I can split that up into sum of the two logarithms here. 2 cubed plus log of 5. And then I can go, okay, the 3 can be over here. So it's going to be 3 log 2 plus log 5. And I can say, oh, okay, log of 2. I know what that number is. I just got to multiply by 3. And I know the log of 5. So I can go 3 times log of 2. Log of 2 is 0.301 plus log of 5 is 0.699. Okay, I'm supposed to do this without the calculator, but I could just figure that out right here. That's going to be 0.903. So multiplying everything in here plus 0.699. So 0.903 plus 0.699 is going to give me a 9, a 9, 15. So 1. Okay, here. Times 0.301 plus log of 5, which is log of 40. Yeah. Okay. Okay, so I got approximately 1.599. And these are approximate. So this is approximate number. And okay. Oh, I made a mistake right here. Oh no, error. That's going to give us 12, 12, 10, 6, 602. Oh my goodness. Okay, it's going to give us 12, 10, 16. It's going to be 1.602. Trying to figure out my answer. It's not matching up. Okay, that one. I found out my mistake. Apparently, I didn't add this right. Okay, so now that's that. Let's get on with this part here, last one, and then we're gonna take a little bit of time to just work on this one here. Log of the cube root of 100. Okay, log of the cube root of 100. Okay, well, how can we do the 100? That's the same thing as log of 100. Because it's a cube root of 100, that's the same thing as exponent to the 1/3. Okay, so just changing the radical to a rational exponent to the 1/3, and then that becomes 1/3 log of 100. And how do we get 100? How do we get 100 from using just 2 and a 5? So 5 squared will give us 25, and then 2 squared will give us the 4. So that gives us 100. That, okay, so that becomes, or we can say 2 times 5 squared, because 2 times 5 is 10, and then 10 squared is 100. Okay, so how can we figure that out? That becomes 1/3 log of 2 squared plus 5 squared. You know what I'm going to do? I'm going to just do a slightly different approach. I'm going to do a slightly different approach because this is being an exponent too. I can just bring that down in there, so that becomes 2/3 log of 2 times 5, and then I can go here 2/3. I can go times log of 2 plus log of 5. Okay, I know what log of 2 is, and I know what the log of, oh, I'm so sorry, log of 2 is and log of 5 is. I can go 2/3. Log of 2 is 0.301. Log of 5 is 0.699. Okay, so let's give you a moment to write that down. Sorry, it was raised up quite a bit. Okay, so I can add those up. That's gonna give me 10. It's gonna give me, it's gonna be 1. So the answer will be 2/3. Okay. So there's an alternative way of doing this. There's quite a, I think at least 2 or 3 possible ways of doing the same thing, and you're gonna get a 2/3. So here's just one of them. There's quite a few. So if you want, you can try them, and you'll see there's another way of doing this. Okay, so that's the answer for that. I think I'm gonna stop right here. Just because it's just getting way too long. I think the next class, well, which is tomorrow, we will talk about we'll continue on with this. But for the meantime, here's the questions that I would encourage you to try. So try these questions. Okay, so let's see here. 4, 5, 9. So you could try page 393. I'll just write it here. Please try page 393. Question number, you can try question number 4. Okay, that's using the question 8. Question 4. Oh, question 5 and 8. 5 and 8. 12 and 13. And then 14. We could probably do 16. So all of these questions that you will be trying out, okay, let me see, because we want to make sure that we don't have a change of base. Mm-hmm. 17 and 18. Oh, I guess all of them. No change of base. Okay, so you can try all of these or some of these, and then tomorrow we will continue on with the change of base formula, and then yeah, we can keep going. Okay, so I'll leave that with you for now. Just quite a bit of stuff to work on. So please try some of these questions, and then tomorrow we will continue on. And yeah, if you have any questions, let me know. Yeah, if there's any specific question that you want me to take a look at or go over with you or go over with the class, yeah, please don't hesitate to ask. Okay, for the meantime, I'm gonna leave this with you, and it's super super important, so please give them a try. It's gonna help us when we move forward to solving logarithm and equation. Okay, so have a good afternoon, have a great um, work on that one, and yeah, we'll keep in touch, and yeah, I guess I'll talk to you later. Okay, bye for now.